We are assuming that they're talking about a traditional clock, not a digital clock. This digital clock's on our hands. The minute hand is 8 millimeters long, and the hour hand is 4 millimeters long. They're asking us how fast is the distance between the tips changing at 1 o'clock. So the two lengths they give us and the length they're asking a question about form a triangle. That triangle is not a right triangle. So I can't rely on right triangle trig or Pythagorean theorem. But I can rely on law of sines or law of cosines. Okay, so I'm going to use law of cosines as my equation that is going to relate the variables. Okay, so I'm asked about dv dt. That's what I'm being asked for. I'm being asked to find how fast the distance between the tips of the hands are changing. So I'm being asked to find dv dt. I can figure out something about that angle. Okay, so I'm not directly told what d theta dt is, but I can find this assuming it's a normal clock that's working correctly. All right, in the problem, they didn't exactly tell me what d theta dt was, but they told me that it's a clock or watch. I'm assuming that it's going to be a watch that's working correctly. And so by reasoning out what I know about time and clocks, I can figure out d theta dt. So my equation that's going to relate the two together is going to be law of cosines. And law of cosines tells me that given any triangle, the relation between the sides is such that c squared would equal a squared plus b squared minus 2ab cosine of theta. So notice theta is opposite that side. Right? So if you're writing out law of cosines, you can write it for any one of the sides, but make sure that this angle is opposite that side. These are opposites of each other, and then the other two legs are the other two sides of the triangle. Now, I know I said don't plug in any numbers, and I explained I was going to clarify that in a minute. Don't plug any numbers in that change throughout the problem. If a number doesn't change, it's okay to plug it in. So, is my minute hand going to change in size? No. Is the hour hand going to change in size? No. So, if you know that some numbers don't change at all throughout the problem, it's okay to plug them in. So, it's okay for me to plug in the 8 squared and the 4 squared. But the angle changes, and so does d. So don't plug numbers in for those. I know they're asking me at 1 o'clock, but that's just one moment in time that they happen to be asking us about. Seconds before 1 o'clock and seconds after 1 o'clock, there are different values. So I'm going to leave this for a minute. Okay, so I did the brainstorming part of the problem. I read the problem. I tried to just figure out what it was about. I identified the rate we were trying to find. I figured out a rate that I'm given. In this case, it's sort of given. I'm still going to have to figure it out, but it's another rate that I can use. And then I devised an equation that tied the variables together. So then once you do that, your next step is to do your implicit differentiation step. So 2 times d, but d changes with time. So I want to put d prime or d dt. Okay, d is a function of time. D is some function of time. I just don't know exactly what function it is. So that's why this is showing up. This is showing up because of the chain rule. And then over here, the derivative of that will just be a 0. The derivative of this will just be 0. And 32 times 2 is where I got 64. But the derivative of cosine is negative sine. So my negative from the sine will cancel that and make it a positive. But theta changes with time. Okay, so again, this is here because of the chain rule. Okay, so d is a function of time. It's plugged inside a square. So the derivative of the square is this, and then chain rule says multiply by the derivative of the inside. Theta is a function of time, so it's plugged inside cosine. So its derivative is negative sine, the two negatives cancel, and then I multiply by the derivative of the inside, which is theta. Okay, now that I have figured that out, I can start to plug numbers in. We have a little bit of figuring to do because d, we're going to need to figure out a number for d. We're going to need to figure out a number for theta and a number for d theta dt. Why don't we do the d theta dt first? We'll and then we'll talk about d. And then we'll talk about theta. Or, yeah, that should be fine. Okay. The minute hand is going around the clock, and how long does it take for the minute hand to make one full rotation? An hour. Okay, so I guess we have to decide, do we want to work in hours or minutes?
60 minutes.
Why don't we work in minutes, okay? So the hour hand, or sorry, the minute hand, that was what we were talking about. The minute hand makes a full revolution, and don't put degrees because we'd have to make some conversions. So think in radians. How many radians make a full rotation?
2 pi.
Okay, so it's making 2 pi radians per 60 minutes. The hour hand, on the other hand, how long is it taking before it actually makes a full rotation?
12 hours.
12 hours, okay? So it makes a full rotation in 720 minutes. And the difference between them is what d theta dt is, and which one you subtract from which kind of doesn't matter. I say kind of in the sense that it's just going to change the positiveness or negativeness of the d theta dt, and so often you can kind of just adjust that in the end. But for the specific point in time that they're asking us, if it's at exactly 1 o'clock, the minute hand is getting ready to overtake the hour hand. And so that angle should be getting smaller. And so d theta dt should be negative. So you actually want to do 2 pi over 720 minus 2 pi over 60, because this is the smaller number minus the bigger number, and that'll give you your negative. But again, if you subtract it in the other direction, all it's going to do is change the positiveness or negativeness of this, and you can easily tack it on at the end, okay? So it's not that big a deal. But technically, I would get 2 pi over 720 minus 24 pi over 720, which would give me negative 22 pi over 720, which is negative 11 pi over 360. Okay, so that's d theta dt. And we'll plug it in a minute, but I'll kind of wait till I get everything before I plug this up. All right, so the D we're going to get by following this formula here. So D squared is equal to 8 squared plus 4 squared minus 64 cosine of theta. And theta is going to be the angle that's between them at 1 o'clock. So just think about it, and I don't care if you answer in radians or degrees because we're plugging it into the cosine. So just think about how many degrees or how many radians are between your hour hand and your minute hand at 1 o'clock.
6.
I'm sorry, I heard somebody say 60, it's not 60.
30. Or not.
Pi over 6.
Pi over 6,
If
yes.
you have 12,
Thinking
you have
degrees.
12 individual ones.
I was gonna achieve
Yeah, so,
You have 2 pi for the whole, and then you want to divide it by 12. You want in 12 different spots.
okay, so either 30 degrees or pi over 6, which, and again, because you're plugging it in the cosine and that's what you're actually evaluating, it doesn't really matter which one you use, but. Okay, so then D squared is equal to 64 plus 16 minus 64 times the square root of 3 over 2. And what is 64 plus 16? 80. Again, if you can possibly wait to round at the very end. You're better off rounding at the end, but what I meant that, notice like I didn't turn this into a decimal just yet. I waited until I plugged it in here.